During this lecture, we are going to be discussing measures of association, but I think these in some of the in some of the in some of the books or some of the lectures, these are also written as measures of effect. So measures of association and measures of effect. Those two words, they are used interchangeably. So before I proceed, I think I just want to acknowledge these slides. I adopted them from Dick Weber. Dick Weber is a lecturer at Charité University in Berlin. So that's where I adopted these slides. They are not my slides. So what I'm going to cover in this session, we're going to cover measures of association and effect. Which these measures, what are these measures which we are going to cover? We're going to cover relative measures or ratios. We'll discuss relative risk, we'll discuss odds ratios, we'll discuss attributable fraction, we'll discuss population attributable fraction. So the risk ratio, the relative risk is the RR, then the odds ratio is the OR. Attributable risk is AF. Then population attributable fraction is the PAF. Then we're also going to discuss absolute difference measures, which is the attributable risk and population attributable risk. We'll describe how to calculate and interpret some of them, and also discuss in which type of study designs do we use some of these measures, because they then, it differs in terms of where we use some of these measures. So as an introduction, remember, as we discussed in epidemiology, one of the important aim in epidemiology is to estimate association between certain exposures and occurrence of disease. So we always want to see if there is a relationship between exposures and occurrence of disease. And how can we do this? We do this by measuring the following. We can measure the relative risk, or we can measure odds ratio, or we can measure the attributable risk or population attributable risk fraction. So I think that's the whole. In analytic epidemiology, we always we say we are assessing risk and exposure, but at some point we might then need to measure this relationship between risk and exposure, to have some some measurement. And for us to do that, we are measuring what we'll be measuring. We'll be measuring the risk and the measures of effect, or measures of risk, or measures of association are the measures which then assist us to quantify this association. So in terms of, as I mentioned from the start of the lecture, measures of association, measures of effect, measures of risk, I might be using these words interchangeably. Yeah, they more or less mean the same thing, although they might differ, depending on interpretation. But in this lecture, I'm going to use them interchangeably. So as I explained, in epidemiology, we are mainly worried about the relationship between exposure and disease. So does incidence of outcome differ? Does incidence of outcome, remember the outcome, it can be outcome and disease. They are the same. So does the incidence of outcome differ depending on the presence of exposure? And the outcome and exposure associated. And so we are looking at this relationship between exposure and disease. Disease can be what? Disease is one of our outcomes. It depends with whatever outcome which you are looking. So does incidence of outcome differ depending on presence of exposure? And the exposure and outcome in the exposure associated. So for the exposure, how do we assess that? We assess if there's a relationship between exposure and outcome. How can we measure this? We can use our measures of effect or measures of association. We have our relative risk, our RR, or our odds ratio, which we can use. Then if if someone then develop a disease because they have been exposed to, to an exposure, we then want to get the attributable risk. But what proportion or what contribution is the risk contributing to develop? What is the contribution of the exposure towards developing the disease, and that is the attributable risk. But for us to really understand some of these issues in terms of how do we measure, one of the key tools which is used in epidemiology is called a 2x2 table. And a 2x2 table is one of the greatest tools and one of the handy tools which is used by epidemiologists, to try to really understand the relationship between exposure and the disease, or relationship between exposure and outcome. So this is how a 2x2 table is structured. When you are writing a 2x2 table, you have your exposures written, and it's written as rows. We have got those who are exposed and those who are not exposed. Then you have got those with disease, and it's those without disease, and those with those with disease and those without disease. Then these are the columns. So in terms of those who are exposed, in terms of exposure, remember, it's not always 100% that if you're exposed to an exposure, you're going to develop the disease. Some will develop the disease and others will not develop the disease. The same, you can have people without the exposure of interest developing a disease, while others will not develop the disease. And then you have your total year. So total for those who are without disease is year. Then total with disease is A plus C. Total without disease is B plus D. Total exposure is this plus this. Then total without exposure will be this. So this is like the typical thing. And if someone is exposed, they are going to develop a disease. And they're going to develop a disease. That's your A. Then these are also the typical. So usually it depends. You can use this 2x2 for several reasons. But if you're using this for disease, it's yeah. But if you're using it for diagnostic tests, you can use it for several other things. This would be like your true positives, and those without exposure, then these are your true negatives. So it depends how we're using this 2x2 table. But understanding how this 2x2 table is organized is very critical, as a student of epidemiology, because that's where we get most of the things. So we are now going to, so this 2x2 table is also called a contingence table. So our measures of association or measures of effect, they differ depending with the type of study. So in this case, we are going to start by describing a cohort study. We are going to start by describing a cohort study. So in this is an example of a cohort study where we wanted to assess the association between smoking and deaths from lung cancer. Using the principles of our, this is an example of a cohort study which was conducted. So people have followed up. Then our exposure, and it was smoking. There are people who smoke and others who did not smoke. Then we followed up those two cohorts of those who smoke and those who didn't smoke to try to see the incidence and to try and see the incidence of cancer. So among those who smoked and developed cancer, there were 150. Then those who did not smoke, but they had no cancer. Those who smoked, but they had no cancer, there were 300. Those who didn't smoke and had cancer were 50. Those who did not smoke and had cancer were 450. Then the total cancer among that is 200. the total of those who didn't have cancer is 750. And then the total of those who were exposed to smoking was 450. Those not exposed to smoking was 500. The 950, this one is our total population, our total study population, which for this study. So in cohort study, for cohort study, we use, in terms of our measure of association, we use what we call a relative risk or a risk ratio. Remember, we want to see what is the difference between those who are exposed and those who are not exposed. So using our formula, remember we discussed in measures of, remember what we see now, what is the difference of risk of getting, of dying from lung cancer among those who smoked and among those who did not smoke. So which means we need to get the risk among smokers. Then we see the risk among non-smokers. And then from there, we can then compute or calculate another measure, which is a relative risk or a risk ratio. How do we calculate this relative risk? So the risk among smokers. So among what is the total number of smokers? There were 450. Out of those smokers, how many developed gene? How many developed lung? How many died? 150 died. So our risk among smokers, becomes 150 over 450. And among non-smokers, what is the total number for us among non-smokers? We had 50, and we have 500 non-smokers. Out of those 500 non-smokers, how many died from cancer? There were 50. So which means our risk in this case is 50 over what? Over 500. We then want to compare now, and so this is coming here. Because the risk among smokers is 150 over 450 is 0.33%. Then the risk among non-smokers is 50 over 500, which gives you 0.01. Then we want to then compare now to get our relative risk, which means we get the risk among those who smoke and the risk among those who don't smoke. We divide 0.33 and 0.1 and we get 3.3. So remember, this is a cohort study. And for cohort study, what do we put? And that's the formula, and which is 3.2. What does this 3.3? What does this 3.3 mean? And this 3.3 means the risk of dying from cancer among smokers is compared to non-smokers is 3.3, or smokers, they are 3.3 times more likely to die from lung cancer as compared to non-smokers. So that's the relative risk. So in terms of formula, this is like our usual 2 by 2, and for cohort study, how are we getting it? We are saying risk among those who are exposed. In our example, we are using those who smoked. And how do we get risk among exposed? Is this one, and it is A over G over A plus B. Risk among unexposed, so it's this over C plus D. Then how do you get our relative risk or our risk ratio? We are then dividing this by what? By this, and it. So the relative risk is the risk ratio, or is often called the relative risk, and this is the formula where now we are now calculating the incidence among those who are exposed and the incidence among those who are not exposed. So your risk ratio, and is this one. So remember, one of the, since this one is a cohort study, and I think I also need to explain that from here. Since this is a cohort study, so in a cohort study, you are following, and you are following people, and you are following people, smokers and non-smokers, and then after some time, you are going to see how many would then develop a disease, which means whatever measure we get, if you divide those who develop, those who die among our total, it's more of like an incidence. And it was, remember, initially we start with a population without the condition, a population of those who are smoking and those who are not smoking. Then you follow them up and then see how many develop lung cancer. So which means it's more like cases now. These are like new cases. I am discussing this why, because we are going to see this where we are now saying incidence among exposed or incidence among unexposed. Why is the incidence? It's because we are following up on new cases which are developing. So you can have a risk ratio, you can have a rate ratio, and so it depends. It depends on how do you calculate this. If you calculate it from incidence proportion, like the risk which you are saying, that's a risk ratio. If you calculate it from it becomes a rate. If you calculate this using incidence rates or percent units of time, so it depends. I hope you remember when we were discussing measures of frequency, we had two. We had risk and rate, and the difference between rate and ratio. The difference was because of the denominators. And this is a cohort study. So in a cohort study, as I said, you'll be following up people, and there's the element of what? The element of time. And so because of that, but because risk ratio or rate ratio, people then use something which is neutral, which is like a relative risk, which more or less means the same with these two terms. What are the possible values of relative risk if you are doing a study? They can vary from 0 up to infinity. They are dimensionless, which means they don't have units. Then a now value, which means a value of 1. How do you get a value of 1? You get a value of 1 if the incidence among the unexposed is the same as the incidence among the unexposed. So it means, in this case, if you get a now value, it means there is no relationship or there is no association between those who are exposed and those who are not exposed. So it is a measure of strength of association between exposure and the disease. How do we interpret a relative risk? As I said, if you have a relative risk of 1, it means there is no association between exposure and disease. There is no association between exposure and disease. It means also, if it's a cohort study, it means the incidence now, and the incidence of whatever outcome we are looking is identical between those which is between the group which is exposed and the group which is not exposed. Then if your relative risk is above 1, there is positive association. And by positive association, we mean which exposure is a risk factor for the disease. Which those who have that risk factor, they are more likely, those with such an exposure, they are more likely to develop the disease. So if it's more than 1, it means it's a risk factor. And people exposed to that are more likely to develop the disease. But if relative risk is less than 1, we call that there's negative association. And that exposure is protective. And I give, for an example, there are some exposures which can get a negative. Let's say we're taking the risk of developing heart conditions, a heart condition among those who exercise and those who do not exercise. So you might realize that those who exercise and those who conduct exercise, or they're part of an exercise team, they run, they do aerobics, whatever sort of exercise they do, they are less likely to develop the heart disease because of that. So that exposure can be a protective factor because it is a negative It is a negative value. So this is an example. How do we interpret our relative risk? This was a cohort of smokers and lung cancer. So we got those who smokers, those who smoked, and those who didn't smoke. Then among those, our outcome was lung cancer. If you then say the incidence among smokers and the incidence among non-smokers for lung cancer, and we divide, if you get a relative risk of 2.5, how do you interpret this? This means smokers are 2.5 times more likely to develop lung cancer than what? Than smokers. Remember, this is a cohort, and it only applies during the time period that corresponds to the follow-up period. So you need to, as you interpret some of these relative risk and some of these measures, they need to be interpreted, depending on the time follow-up. If the time of follow-up is there, you can actually, after a follow-up period of 2 years, smokers were 2.5 times more likely to develop lung cancer than non-smokers. So remember, as I highlighted in the previous slide, this measure is dimensionless, so it doesn't have units, but we are just comparing, towards two groups. Then this is enough for for cohort studies. Then if you go to the next type of study, which are our case control study. So this is an example of a case control study of smoking and myocardial infection. This is an example of our 2x2G table. I hope you understand the difference between a cohort study and a case control study. In a cohort study, we assess our study participants based on exposure. Then we follow up to see either retrospectively or prospectively to see if they develop the outcome. And we are assessing, we have the exposure, then we look for outcome retrospectively or prospectively. But for case control study, there is no follow-up, and there is no follow-up element. There is no follow-up. We are selecting our findings based on on outcome or a disease, and we then look for exposures. And because of this, I think I've mentioned this several times in the previous lecture, on the issue of temporality, and in terms of time, we can then not really assess we cannot assess incidence in case control studies, and because we are assessing exposure at outcome, we are starting with our outcome, and we are collecting these things more or less at the same time. This is an example of a case control study where our cases were those with myocardial infection, our controls those without myocardial infection. So in terms of smoking and our exposure in this case was smoking. Those with myocardial infection and they smoked, they were 60. Those who had they smoked but they didn't have myocardial infection, they were 200. And 260 was the total of smokers. Then those who didn't smoke and developed myocardial infection were 20. And those who did not smoke and they did not develop myocardial infection were 100. Were 100, and the total was 120. So the total of those with myocardial infection was 80. Then the total of those with who didn't develop myocardial infection was 300. And our total population, our total population was 380. So in case control studies, we don't we can, since we are unable to calculate incidence. In case control studies, we use as our measure of association, which we use is called, we use odds ratios. And how do we how do we calculate our odds? Our odds and the odds of exposure among cases. And how do you calculate this? Is the proportion of exposed cases among proportion of unexposed cases. So remember, it's the same thing, the same way we draw a 2 by table. Our cases, those are the disease, our controls and no disease, exposure or no what, or no exposure. So the odds of exposure among cases is calculated as proportion of exposed and among proportion of exposed cases over proportion of unexposed cases. How many cases were, what is the proportion of cases and proportion of exposed cases? So we would A, and our total number of cases is A plus C. What is the proportion of exposed cases? Is A divided by A plus C. What is the, if you do the maths, if you say A and what is the proportion of unexposed cases? Is C over A plus C. And if you do the maths, unasara wina A over G, A over C. Then we go to odds of exposure among controls. And how do you get our odds of exposure among controls? Is the proportion of exposed controls over proportion of unexposed controls. Exposed controls B, unexposed controls and D. Total number of controls is B plus what? Plus plus D. So what are the proportions? Is B over B plus D divided by D over B plus G plus D, and you get B over D. Then our odds ratio, remember, these are odds. And these are what? These are odds. But our odds ratio now, we are then getting the odds of exposure among cases divided by odds of exposure among what? It's now a ratio. So for that ratio, we then divide A over C divided by B over G over D, and you get AD over BG C. So that's the formula of our odds ratio. But if you look at this formula now for odds ratio for case control study, we call it a cross product. It's a cross G product. By cross product now, it's A times D divided by C times B, which is here. So that's our formula for odds ratio, which is a measure of association in case control study. So this is our example, and this is our example. So for case control studies, and we are looking at this. So what is the odds among cases? The odds among cases, we get it what is the proportion of our total cases, and at this. Our total cases, they are 80, and which of our cases which are exposed, they are 60. Cases not exposed, they are 20, and so the proportion, so this is 60 over 80 divided by 20 over G60, we get our odds among cases. To get our odds among controls, our total controls are what? 300. Exposed controls 200. Unexposed controls 100. The proportion of unexposed controls is 200 over 300. The proportion of exposed controls is 200 over 300. Then the proportion of unexposed controls is 100 over 300. Then you get your odds among controls. And which is this 60, the odds in cases. Sorry. Let me go back here. Or it's the same thing. Really, it's the same thing. But if you do your formula, it will end up cancelling whatever and dividing as it is. But if you do it properly, and for this one, you're saying this, and the proportion of the proportion of exposed cases over non-exposed cases. So you're saying 16 and it divided by, but if you do the maths, you end up getting 3 here and you end up getting G2. Then our odds ratio, these are like really the summarized format. But if you, so the odds among cases will be 60 over 20, the odds among controls will be 200 over 100, and you get 3 here and you get 2. Then if you do our odds ratio will be 3 divided by 2 and you get 1.5. And the other easy formula for you to get our odds ratio is your cross product, and where you're going to say 60 times 100 divided by 20 times 200, which is your cross product, and which is A over times D divided by B times C, which means you get your 1.5. And this is the same formula if you are dividing this with this over this over this, and it will simplify to A over C to B over C. But if you remember from this, you'll be using this as the denominator, but if you cancel, you end up having A over G, A over C. How do you interpret our odds? What are the characteristics of odds ratio? They also have the same, more or less the same, they also have more or less the same meaning. They have the same meaning with our relative risk, where they range from 0 up to infinity. They're dimensionless, which means they've got no value. If you've got a null value, and if you have an odds ratio of 1, it means there's no association. So it is also a measure of the strength of the association between exposure and and disease. So how do you interpret our odds ratio? Is the same interpretation which we use for same as relative risk. If your odds ratio is 1, it means if your odds ratio is 1, it means there's no association between exposure and disease. Then it also means the odds of exposure now are identical between the groups. If it's more than 1, there's a positive association, it's a risk factor. If it's less than 1, it means the exposure is protective. And I think I described these things in the previous lecture, in the previous example. So this is an example of a case control study where the researchers wanted to see the use of mobile phone and risk of developing risk of use of mobile phone and development of brain tumor. So our outcome was brain tumor, no brain tumor. And then below our exposure, mobile phone and no mobile phone. After getting the odds, and after dividing and getting our odds ratio, the odds ratio was 1.5. How can this odds ratio be the interpretation of this? Now we are using odds. So the odds of getting a brain tumor, which is called a meningioma, among cases, and the odds of getting the odds of getting a meningioma among cases is 1.5 more times to those who use mobile phone than those who do not use. So one of the mistakes which people tend to do is to then interpret this as saying the risk is 1.5 times. No, it's not the risk which is 1.5 times, but we are saying in this case the odds. It is the odds which are 1.5 more times among mobile phone users as compared to those who didn't use the phone. So just get that interpretation. Please don't fall in the trap of interpreting interpreting the odds ratio as a risk. No, in this case, you interpret it as what? As the odds. So this is the correct interpretation. This is a wrong example, but let's assume it was the risk of mobile phone among meningiomas, which means meningiomas, they have 1.5 times higher odds of being meningioma cases have a 1.5 higher times odds of using a cell phone than controls. I'll correct this example. I'll correct the wording. And I'll correct the wording before I share the slides with you. Then it's very intuitive but scientifically correct. In terms of really assessing risk, case control studies, they are more efficient than cohorts and in assessing risk. So, but remember, yeah, we'll discuss some of these things in the next lecture. Is there a relationship between relative risk and odds ratio? Remember, relative risk, we use them for cohort studies where there's an element of follow-up. If you look for case control studies, for cohort studies, it's the same 2x2 table, and it's the same 2x2 table. But how we calculate an odds ratio is different from the way we calculate an odds ratio. But we can use all those tables to calculate. We can use, we can calculate either a relative risk or an odds ratio on a table. And so it doesn't really, what really guides, well, the measure which you calculate is just the study design. But as we explained in the other lecture, usually the relative risk where there is follow-up, that's the best. But the odds ratio is a good estimator of the relative risk under the following circumstances. If the disease is rare, or if the relative risk is close to 1. If it's close to 1, it just means there's no association. So if there's no association between an outcome and exposure, and usually the odds ratio closely estimate the relative risk. But remember, we use case control studies for rare diseases. So because of that, the odds ratio now is a good estimator of risk. So I think I've been discussing about this terminology, and where you are going to a relative risk is also called a risk ratio or a rate ratio, depending on your denominator. What are you using to calculate? If you are using your percentile, yes, it then becomes a rate ratio. If you are using your cumulative risk, then it becomes a risk ratio. But the relative risk is RR is more like the neutral terminology. Odds ratio, they're sometimes called relative risk. That's wrong. That's not correct. Although the two, they can estimate each other depending on the condition, and based on the conditions we discussed before. They are not the same. They are not the same. So it's not correct to say odds ratio and relative risk is the same thing. It's the same thing. We have other type of relative risk, like a hazard ratio. This one, the hazard ratio, we get it when you are doing survival analysis, and where so I think but just understand the hazard ratio is an example of a relative risk, and we use it when you're analyzing survival analysis or survival data. So I think for this first part we'll end here. Then we'll discuss the attributable risk and attributable fraction in the next lecture.